Welcome to our comprehensive guide on Java's completable future. In this video, we'll explore how completable-future has revolutionized asynchronous programming on the JVM since Java 8. If you've ever struggled with managing multiple threads or coordinating asynchronous tasks, this API is a game changer. We'll start by understanding what completable-future is, why it's important, and how it fits into the modern Java landscape. By the end, you'll have a solid grasp of its core features and how to use them effectively in your own projects. Let's dive in and unlock the power of asynchronous programming in Java. ComplettableFuture is a class found in the java.util.concurrent package. It implements both the Future and CompletionStage interfaces, providing a rich API for asynchronous programming. Think of it as a container for the result of a future asynchronous operation. This means you can start a task now and retrieve its result later without blocking your main thread. ComplettableFuture makes it easier to write non-blocking, scalable applications by handling the complexity of thread management for you. It's a foundational tool for modern Java developers working with concurrency. The first way to create a completable-future is with runAsync. This method is perfect when you want to run a task asynchronously but don't need a return value. For example, you might want to log an event or trigger a notification without waiting for a result. The runAsync method schedules your task on the common ForkJoinPool by default, but you can also provide a custom executor if you need more control over threading. This flexibility makes it easy to fire off background tasks and keep your main application responsive. Next up is supplyAsync. This method is used when you want your asynchronous task to return a value. It takes a supplier as input, which means you can define any computation that produces a result. The returned completable-future holds the result, and you can retrieve it later using the get method. Remember, calling get will block the current thread until the result is available, so use it wisely. Like runAsync, supplyAsync uses the common ForkJoinPool by default, but you can pass a custom executor for more control. When you need the result of a completable-future, you can call the get method. This is a blocking call, meaning the current thread will wait until the asynchronous computation is complete. While this is sometimes necessary, it's important to avoid blocking in performance-critical code. Instead, try to compose further asynchronous actions or use non-blocking techniques wherever possible. Understanding when to block and when to stay asynchronous is key to writing efficient Java applications. By default, both runAsync and supplyAsync use the common ForkJoinPool for task execution. However, there are times when you need more control over thread management, such as limiting the number of concurrent tasks or isolating workloads. In these cases, you can provide a custom executor service. For example, you might use Executors.newFixedThreadPool to create a pool with a specific number of threads. Passing this executor to your completable-future methods gives you fine-grained control over how and where your tasks run. Sometimes, you already have a value and want to create a completable-future that is already completed. The completedFuture method is perfect for this scenario. It's commonly used in testing or when you want to seed a pipeline with a constant value. By wrapping an existing value in a completable-future, you can easily integrate it into asynchronous flows without scheduling new work. This method is simple but powerful for building flexible and testable code. One of the most powerful features of completable-future is the ability to chain tasks together. The thenApply method allows you to transform the result of a completed future synchronously. For example, you might fetch order details and then extract the price. This keeps your code clean and readable, as each step in the pipeline is clearly defined. Use thenApply when your transformation does not return another completable-future. If you want to transform the result of a completable-future asynchronously, use thenApplyAsync. This method schedules the transformation on a separate thread, allowing your pipeline to remain non-blocking. It's especially useful for CPU-intensive or I/O-bound operations that shouldn't run on the main thread. Like other async methods, you can provide a custom executor for even more control. This flexibility helps you build responsive and scalable applications. When chaining asynchronous tasks, you might end up with nested completable-futures. The thenCompose method helps you flatten these into a single pipeline. It's similar to FlatMap in functional programming. Use thenCompose when your transformation itself returns a completable-future. This keeps your code clean and avoids unnecessary nesting, making it easier to manage complex asynchronous flows. Sometimes, you want to perform an action when a future completes, but you don't need to return a value. The thenAccept and thenRun methods are designed for this. thenAccept consumes the result, while thenRun simply runs a task when the future completes. These methods are great for triggering side effects, such as updating the UI or logging, without altering the result pipeline. When you need to wait for multiple asynchronous tasks to complete, use the allof method. It returns a new completable future that completes only when all the supplied futures are done. This is perfect for scenarios like fetching data from multiple APIs in parallel. Once all tasks are finished, you can collect and process their results together, making it easy to coordinate complex workflows. If you only care about the first completed task, the anyOf method is your friend. It returns a completable future that completes as soon as any of the supplied futures finish. This is useful for racing multiple sources, like searching from cache, database, or an API, and using whichever result arrives first. Remember, the result type is object, so you'll need to cast it as needed. The thenCombine method allows you to merge the results of two independent futures. For example, you might fetch user details and their orders in parallel, then combine them into a single object. This method is essential for orchestrating complex asynchronous workflows, where results from different sources need to be combined before further processing. After using all to wait for multiple futures, you'll often want to collect their individual results. This requires unpacking each future, typically using the join method. By streaming over your list of futures and joining each one, you can gather all results into a single collection. This pattern is common when aggregating data from multiple synchronous sources. The anyOf method returns a completable future of type object. This means you'll need to cast the result to the expected type before using it. For example, if you're racing multiple search methods, cast the winning result to string or the appropriate type. This flexibility allows anyOf to handle diverse tasks, but always ensure you cast safely to avoid runtime errors. Both join and get methods retrieve the result of a completable future, but there's a key difference. The get method forces you to handle checked exceptions, while join wraps failures in an unchecked completion exception. This makes join more convenient in many cases, especially when you want to avoid cluttering your code with try-catch blocks. Choose the method that best fits your error handling strategy. Handling errors in asynchronous code is crucial. The exceptionally method lets you recover from exceptions by providing a fallback value. For example, if fetching a user profile fails, you can return a default response and increment a metrics counter. This approach keeps your application resilient and ensures that failures don't break the entire pipeline. The handle method gives you even more control by allowing you to inspect both the result and any exception. You can decide how to proceed based on whether the computation succeeded or failed. For example, you might log an error and throw a custom exception if something goes wrong, or simply return the result if everything is fine. This method is powerful for robust error handling in complex workflows. Long-running tasks can be problematic, so it's important to set timeouts. The timeout method lets you specify a maximum duration for a completable future. If the task doesn't complete in time, a timeout exception is thrown. This helps prevent your application from hanging indefinitely and allows you to handle slow operations gracefully. Sometimes, instead of throwing an exception on timeout, you want to provide a default value. The completeOnTimeout method allows you to specify a fallback result if the task doesn't finish in time. This keeps your application responsive and ensures that users always get a result, even if it's a default or degraded response. Java 21 introduced virtual threads, a groundbreaking feature that allows you to run millions of threads efficiently. CompletableFuture works seamlessly with virtual threads. By using Executor's.newFixedThreadPool executor, you can schedule asynchronous tasks on lightweight threads, making your applications even more scalable. This integration opens up new possibilities for high concurrency workloads. Leverage virtual threads with CompletableFuture. Simply create a virtual thread executor using Executor's.newFixedThreadPool executor. Pass this executor to your supplyAsync or runAsync methods. This setup allows you to run massive numbers of concurrent tasks without overwhelming your system, thanks to the lightweight nature of virtual threads. It's a major step forward for Java concurrency. Imagine you need to generate multiple reports in parallel, such as sales, inventory, and revenue. With virtual threads and CompletableFuture, you can launch each report generation as a separate task. Once all reports are ready, you can collect their results and process them together. This pattern is efficient and easy to implement with the new Java features. Structured concurrency is an exciting preview feature in Java 25. It offers a cleaner and safer way to manage concurrent tasks. Instead of juggling multiple completable futures, you can use structured task scope to group related tasks and manage their lifecycles together. This approach simplifies cancellation, error handling, and result aggregation, making your code more maintainable. Structured task scope is at the heart of structured concurrency in Java. It allows you to start multiple tasks within a defined scope and ensures they are all completed or canceled together. This makes it easier to reason about your program's concurrency, avoid resource leaks, and handle errors consistently. As this feature matures, expect it to become a standard tool for Java developers. ComplettableFuture remains a valuable tool for many scenarios. Use it to parallelize independent I/O-bound calls, orchestrate CPU-bound work where results depend on each other, or bridge callback-based APIs into a fluent, composable model. It's also great for implementing timeouts, retries, and fallbacks around asynchronous operations. Knowing when to use ComplettableFuture versus newer features is key to effective Java development. One of the best use cases for ComplettableFuture is parallelizing independent I/O-bound operations. For example, you might need to fetch data from several APIs at once. By launching each call as a separate ComplettableFuture, you can maximize throughput and minimize waiting time, leading to faster and more responsive applications. ComplettableFuture is also useful for orchestrating CPU-bound tasks where the output of one computation feeds into the next. By chaining futures, you can build complex processing pipelines that remain efficient and easy to read. This approach is ideal for data processing, analytics, and other compute-intensive workloads. Many legacy APIs use callbacks for asynchronous operations. ComplettableFuture makes it easy to bridge these into a more modern, fluent, and composable model. By wrapping callback results in ComplettableFutures, you can integrate old and new code seamlessly, improving maintainability and readability. ComplettableFuture provides built-in support for timeouts and makes it easy to implement retries and fallbacks. By combining methods like timeout, complete on timeout, and exceptionally, you can build robust asynchronous operations that handle failures gracefully and keep your application running smoothly. Let's recap the key features of ComplettableFuture. It allows you to compose asynchronous pipelines, control threading, and coordinate multiple tasks without dealing with low-level concurrency APIs. Its rich set of methods for chaining, combining, and handling results makes it a versatile tool for modern Java development. Whether you're building web services, data pipelines, or desktop applications, ComplettableFuture can help you write efficient and maintainable asynchronous code. Get the most out of ComplettableFuture. Follow some best practices. Avoid blocking calls like get and join in performance-critical code. Prefer chaining and composing futures to keep your code non-blocking. Use custom executors for better control over threading. Always handle exceptions to prevent silent failures. And finally, stay updated with new Java features like virtual threads and structured concurrency for even more powerful concurrency models. While ComplettableFuture is powerful, there are some common pitfalls to watch out for. Blocking the main thread can lead to performance issues. Forgetting to handle exceptions may cause silent failures. Overusing the common ForkJoinPool can lead to resource contention. Always consider the impact of your concurrency choices and test thoroughly under load. Testing asynchronous code can be challenging, but ComplettableFuture makes it easier. Use completedFuture to seed pipelines with known values. Combine futures to simulate complex workflows. And always verify that your error handling and timeouts work as expected. With the right approach, you can write reliable tests for even the most complex asynchronous logic. Debugging asynchronous code requires a different mindset. Pay attention to thread usage and task scheduling. Use logging and metrics to track the flow of data and spot bottlenecks. Tools like thread dumps and profilers can help you identify issues in complex pipelines. With practice, you'll become comfortable diagnosing and fixing async bugs. As structured concurrency matures, consider migrating your code to take advantage of its cleaner concurrency model. Start by identifying areas where you manage groups of related tasks. Refactor these to use structured task scope, which simplifies lifecycle management and error handling. This transition will make your code more robust and easier to maintain. Java is constantly evolving, with new features and APIs being added regularly. Stay updated with the latest releases, especially around concurrency and asynchronous programming. Follow official blogs, join developer communities, and experiment with new features like virtual threads and structured concurrency to keep your skills sharp. Deepen your understanding of ComplettableFuture and modern Java concurrency. Explore official documentation, online tutorials, and books. Practice by building small projects and experimenting with different concurrency patterns. The more you use these tools, the more confident you'll become in writing efficient, scalable Java applications. ComplettableFuture is used in a wide range of real-world applications, from web services and microservices to data processing pipelines and desktop apps. Its flexibility and power make it a go-to choice for handling asynchronous workflows, especially when performance and scalability are critical. How does CompletableFuture compare to other concurrency APIs like Future, ExecutorService, or reactive frameworks? CompletableFuture offers a more fluent and composable model, making it easier to build complex pipelines. While reactive frameworks provide even more advanced features, CompletableFuture strikes a balance between simplicity and power for most use cases. The future of Java concurrency is bright, with features like virtual threads and structured concurrency leading the way. CompletableFuture will continue to play a key role, especially as a bridge between traditional and modern concurrency models. Stay curious and keep learning to make the most of these evolving tools. In summary, CompletableFuture is a powerful and flexible API for asynchronous programming in Java. It simplifies thread management, enables complex workflows, and integrates seamlessly with new features like virtual threads. By mastering its core concepts and best practices, you'll be well equipped to build high-performance, scalable Java applications. Ready to take your Java skills to the next level? Start experimenting with CompletableFuture in your own projects. Try out different methods, combine them with virtual threads, and explore structured concurrency as it becomes available. The best way to learn is by doing, so don't hesitate to dive in and build something amazing. Thanks for joining this deep dive into Java's CompletableFuture. We've covered its core features, best practices, and how it fits into the evolving Java concurrency landscape. Keep exploring, stay updated, and continue building robust, asynchronous applications with confidence. Happy coding!